express f of x is equal to sine x minus cos x in the form f of x is equal to r cos x plus alpha. Hence, or otherwise, solve the equation sine x minus cos x is equal to 1. Compliment of the season to you all, my lovely viewers. This is Donald Siame, author of Hidden Mathematical Genius Within Revealed. Okay, so the first thing to do here, since we want to express this in this form, so what you do, you get this form r cos x plus alpha, you expand it, and you equate the coefficients of sine x and cos x to this. Okay, so solution, you start with r cos x plus alpha. So you expand this. There is an identity for this. Just say this is equal to, it's r cos x cos alpha. So for cos, if you have plus, it changes to minus. So we are going to have minus here. So minus, then r sine x sine alpha. Okay, so we have expanded. Then what you do is the coefficient of here we have sine x. Sine x, the coefficient of sine x here is 1. What is the coefficient of sine x here? So sine x here, if you remove sine x here, we are going to remain with minus r sine alpha. So minus r sine alpha is the coefficient of x from our expansion here. Okay, so minus r sine alpha is equal to the coefficient of x from our equation is what? It's just 1. So minus r sine alpha is equal to 1. And this will be our equation 1. Okay, then equation 2, we get the coefficient of cos x. So coefficient of cos x here, if you remove cos x here, we are going to remain with r cos alpha. So we have r cos alpha is equal to, so what is the coefficient of cos x in our initial equation? So the coefficient here, there is a minus here, so the coefficient will be minus 1. So r cos alpha is equal to minus 1, and this will be equation 2. Okay, now the idea is to solve for r and alpha. So what we can do here, for us to help us calculate the value of r and alpha, we can divide equation 1 by equation 2, so that the r's will cancel. Then we are going to have tan alpha, and this tan alpha will help us to calculate the value of alpha. Okay, so we say divide equation 1 by 2. Okay, so we are going to have minus r sine alpha over r cos alpha is equal to 1 divided by minus 1. Now the r and r will cancel, the minus and minus will also cancel. Then we know that sine alpha divided by cos alpha is going to give us tan alpha. So we have tan alpha is equal to 1. Then for us to remain with alpha, we are going to introduce tan inverse to both sides of the equation. So if you introduce tan inverse here, the tan inverse and tan will cancel out. So we'll just remain with the alpha. So we are going to have alpha is equal to tan inverse of 1. Okay, and what is tan inverse of 1? Tan inverse of 1 is 45 degrees. So alpha is equal to 45 degrees. So that is the value of alpha. Then we go to the value of r. So the value of r, we can use either equation 1 or equation 2. Okay, let us use equation 1. So from equation 1, we have minus r sine alpha is equal to 1. We know that alpha is 45, so then we can make r the subject here. So we are going to remain with r is equal to minus 1 over sine alpha, and alpha is 45 degrees. So we are going to have sine 45 degrees. Okay, so r is equal to minus 1 over, what is sine 45 degrees? Sine 45 degrees is supposed to be 1 over square root of 2. Yes, it's 1 over square root of 2. Now, this is division. We have minus 1 divided by 1 over square root of 2. So the division will change to multiplication, and this fraction will interchange. Okay, it's like this. Minus 1 divided by 1 over square root of 2. So this will interchange when you have multiplication there. So minus 1 times square root of 2 over 1. Okay, so we have minus 1 times square root of 2. Then divided by 1. It's just minus square root of 2. So r is equal to minus square root of 2. Okay, so we have the value of r and the value of alpha. So therefore, f of x is equal to, so we are f of x is equal to, so we are expressing this sine of x minus cos of x in the form of r cos x plus alpha. So we have the value of r and we have the value of alpha. So r is minus square root of 2 and alpha is 45 degrees. Okay, so f of x is equal to, r is minus square root of 2, then we have cos of x plus alpha is 45 degrees. So we have expressed it in the form of r cos x plus alpha. So this is the answer. Now we are not done. Okay, so according to the question, it says hence or otherwise solve the equation sine x minus cos x is equal to 1. So sine x minus cos x is just this same function we are from expressing. Okay, so where there is sine x minus cos x, we are going to put the minus square root of 2 cos of x plus 45 degrees, then equal to 1. Okay, so we have sine x minus cos x is equal to 1. Okay, so where there is sine x minus cos x, we are putting minus square root of 2, then cos x plus 45 degrees is equal to 1. So we need to solve for x. So what are we going to do here? Okay, so the easiest way of calculating for x is first to find the value of this whole thing, x plus 45 degrees. So what you do is, where there is x plus 45 degrees, we are going to put just a single term so that we calculate it easily. So we can just say let x plus 45 degrees equal to, we can use phi. Okay, so we are going to have minus square root of 2 cos phi is equal to 1. Now our job here now is to calculate the value of phi. Okay, so what we do is we're going to divide both sides by this minus square root of 2. So cos phi is equal to minus 1 over square root of 2. Okay, now to get the value for theta, where cos phi is negative, what you do is we can first introduce the cos inverse to both sides. The cos inverse. Now, since we want to get the value of theta, that is the angle in the first quadrant in this case, this minus, we are not going to consider it. Okay, you just take this value as a positive. So you say theta is equal to, so my theta in this case is just the angle in the first quadrant. So you say cos inverse of 1 over square root of 2. Okay, so theta is equal to, what is cos inverse of 1 over square root of 2? Okay, it's supposed to be 45 degrees. Yes, it's supposed to be 45 degrees. It's 45 degrees, yes. So we have 45 degrees. Now this theta is not part of the solution set, because we need to find the values of phi where cos is negative. So cos is negative in the second quadrant and fourth quadrant. Second quadrant and third quadrant. So in third quadrant and second quadrant. So how do you solve for phi in the second quadrant? So the formula is just you say phi is equal to, so in the second quadrant it's 180 degrees minus theta. Now this theta is the angle in the first quadrant. Okay, so phi is equal to 180 degrees minus, okay, minus theta is 45. So 180 degrees minus 45 degrees. What is the answer? So phi is equal to 180 minus 45, that is 135 degrees. Okay, 135 degrees. Okay, so that is our first solution for phi. That is in second quadrant. So the other quadrant where cos is negative is in the third quadrant. And in the third quadrant, phi is equal to, okay, let me say this was second quadrant. Now we are in third quadrant. So in third quadrant, phi is equal to 180 degrees plus theta. So phi is equal to 180 degrees plus 45 degrees. So what is 180 plus 45 degrees? Yes, it will give us what? 220 25 degrees. So these are the values of phi, 135 degrees and 225 degrees. These are not our solutions. We need to solve for x, not for phi. And remember that we let phi to be x plus 45 degrees. So where there is phi is x plus 45 degrees. Okay. So the first one we have 35. So you say x plus 45 degrees is equal to 135 degrees. Then you solve for x. So what you do here, to remain with x from this side, the opposite of plus 45 is minus 45. You can subtract 45 to both sides of the equation. Minus 45 here will cancel out this 45. So we have x is equal to 135 degrees minus 45 degrees. And what is 135 degrees minus 45 degrees? Yes, that is 90 degrees. So x is equal to 90 degrees. Then you come to the second one. In the third quadrant, we had 225 degrees. So again we say x plus 45 degrees is equal to 225 degrees. Again, you say, to remain with x here, we subtract 45 to both sides of the equation. So if you subtract 45 here, it will cancel out plus 45. So I remain with x. So it will be x is equal to 225 degrees minus 45 degrees. Okay, so x is equal to, so what is 225 degrees minus 45 degrees? Yes, it's 180 degrees. So we can say therefore x is equal to 90 degrees and x is equal to 180 degrees. Okay, so those are the two solutions for x. Thank you so much for your time.